about the introduction to operating system. So the book that I'm referring to is the book, what we call it as Dragon Book by Galvin. So Operating System and Concepts by Galvin. Okay. So this in this first introduction chapter, these are the topics that are going to be covered. So what your operating system do, so computer system organization, then computer system architecture, that computer system structure, then operating system structure, then operating system operation, then process management, memory management, storage management, then we have computing environment, then open source operating system. So we are going to discuss on these topics for the first chapter. Okay, so the first question is, what is the objective of this chapter? So it's going to describe the basic organization of your computer system, and it's going to give you an idea of major components of a operating system, and it will give you an overview of many types of computing environment, and we're going to see some open source operating system as well. So the first thing is, what is an operating system? So every one of us have been using operating system in our day-to-day life, either it's Windows, Linux, or Android for phone, or some other OS related to embedded system as well. So what is an operating system? So an operating system is nothing but a program that acts as an intermediary between a user of a computer and the computer hardware. So a computer hardware cannot run alone, so it needs some program, and that program is the operating system. So your operating system is responsible for the proper running of your computer hardware. Okay. So it's going to act as the intermediary between the user of a computer and the computer hardware. So the main goal of this operating system is it executes user programs and makes solving user problem easier. Okay. So when we use operating system, it makes the user unaware of what is going on inside. It doesn't have to bother. So it just makes things easier for the user. Then your operating system make the computer system convenient to use. So even a person who have like little knowledge about programming, or who doesn't have any knowledge about programming or what is going on inside this, can also run a computer, because of by making it easier using this operating system. So, and your operating system is also responsible for using the computer hardware in an efficient manner. Okay. Now, the next thing is, I think everyone has been studying this thing in your previous classes, or even in your high school also. What are the components that are constituted in a computer system? So your computer system may have your hardware, it will have your operating system, then it will have your application programs, then it will have user program. Okay. So we can divide our computer system into 4 components. So the first one is hardware. The foremost and the important thing is hardware. So once you have hardware, the remaining are going to work on it. Okay. So your hardware is going to provide the basic computing resources. So it's going to provide CPU, memory, input, output devices. So those are the hardwares. Then comes next operating system. So as we know, your operating system is a program, and it's going to control and coordinate use of hardware among various applications and users. Okay, so when we say a program or a or a software, we have two types of software, right? One is system software and another one is application software. Okay, so your operating system is a system software. Okay, that are required to run a system. So when we have an application software or application program, it is meant for some specific tasks. So so next we have this application program. So it's defined the way in which the system resources are used to solve the computing problems of the user. So as I mentioned, when we have this application program or application software, it is meant for some particular tasks like word processors, compiler, web browser, database system, video games, whatever the application or software that we use belongs to this application software. So your web browser, Chrome, your Microsoft Word. So those are all application software. Okay. Then the last component and the foremost important is your user. So once you have all these things, then you'll have a user to use this. So your user may be a person or a machine or other computer. Okay. So these are the components of your computer system. So if we look over here, so this is how it is. So you'll first require this computer hardware. Above this only we are going to require operating system. Once we have operating system, then only we can use this system and application programs. Okay. Then we can have a number of users. So the next is what operating system do. Okay. Just a second. So what operating system do? Okay. So we can view what operating system do from different view. It can be from user view or it can be from system view. Okay. Like from different point of view, we can say that operating system mean different thing. So when we look from a side of a user, so the main thing is operating system is going to give convenient, then ease of use and good performance from point of a user. Okay, what a user demand is convenient, ease of use and good performance. And if we look from a system point of view, we can have different views on it. Like if we are talking about shared computers such as mainframe and mini computer, then we have to make sure that the operating system makes all the user happy, meaning that the operating system must maintain all the user with the resources properly so that all the users are equally share the available resources. And then when we talk about this workstation, so users of this dedicated system such as workstation, they must have dedicated resources but frequently use share resources from server. Okay, so when we talk about this workstation, your operating system must resolve that the available resources are shared properly. Okay, and when we talk about handheld computers, the operating system focuses more on its usability and battery life. So for example, when we have a mobile phone, we focus more on its battery life and usability. We cannot fit in whatever that we use in our computer or laptop in a mobile phone, right? So the operating system in this case focuses more on usability and battery life, but it may have resource poor, meaning that we cannot. So in our computer, we have around 1 TB or even 500 GB as memory, but we cannot have the same in our mobile, right? So the resources may be reduced, but our aim to use operating system in this case is to optimize for usability and battery life. Okay. Then we may have some computer that have little or no user interface, such as embedded computers in devices and automobiles. So when we are talking about this embedded computer and in devices and automobiles, the operating system has less or little user interface. So this is how we can view operating system from user point of view or system point of view. Okay. So the next thing is operating system definition. So we can look on operating system as resource allocator or control program. It's program. So whatever the resources a system has, the management is totally depend on the operating system. Okay. Just a second. So your operating system can be treated as a resource allocator, meaning that whatever the resources that the process or any user is requested, the operating system is responsible to give it or not, and maintaining that all the resources are maintained efficiently. So your OS is going to manage all the resources available. Then it's going to decide between conflict requests for efficient and fair resource use. Meaning that if we have different users or a different process requesting for some resource, then it is the responsible of the operating system to allocate the resources to a particular process or user. Okay. Making sure that it doesn't give any conflict. Then from the point of control program, so your operating system is going to control execution of your program to prevent error and improper use of the computer. So in short, your operating system does a big role in resource allocation and the program control. So everyone, are you guys following it or not? Do you have any problem with my audio or the screen? So I assume that everyone is following me. So the next is computer system organization. Okay. So in this we have so one or more CPUs, then we'll have device controller, then we'll have connected them through a common bus providing access to a shared memory. So when we have computer system organization, it's going to contain your memory, then it's going to contain your CPU, then disk controller, USB controller, graphics adapter, and many other components. They are being connected through a common bus, and there will be concurrent execution of CPUs and the device competing for the memory cycle. So here memory cycle refers to the sequence of this execution of your programs. Okay. So in this computer system operation, so your input output device and the CPU can execute concurrently. Okay, so your input output devices and the CPU are going to work at the same time, and they can communicate and execute concurrently. Okay, so then the next point is device controller is in charge of a particular device type. So every device will have its device controller, and it's going to be and the device controller is going to be the in charge of the particular device type. So it's just like when we have installed a uh, our operating system, when we use like Windows XP, at that time we require a driver for either its audio or video. So we used to install device driver for all those components. So here this device driver is going to make sure that the device is working properly. Okay, so your each device controller has a local buffer. So local buffer is a small memory, okay, to make things work faster. Then your CPU moves data from or to main memory or to or from to local buffer. So your input output is from your device to the local buffer of your controller. So, and your device controller informs CPU that it has finished its operation by causing an interrupt. So these are the operations that may be happening inside a computer system. And when a device has completed its operation, so an interrupt, so it is nothing but a signal, so which is given by this device controller informing the CPU that that particular device has completed its operation and the resources is available, so that the CPU can allocate it to another. Right. Then the next is storage structure. So when we talk about storage, we know that we have this main memory, then we have secondary memory type, right? So your main memory is only a large storage media that the CPU can access directly. So your RAM, random access memory are your main memory, so which are volatile. Okay, once the power is gone, the memory is erased. Okay, so you'll have this main memory, but then we require much larger storage size, so we have this secondary storage. So extension of main memory that provide large non-volatile storage capacity. So non-volatile, right? Then so we have this hard disks or hard drives. So these are your secondary storage. Okay, so this will consist of your tracks. Then it's then we have another type of drive, that is solid state drive. So here it will be faster and it will also be non-volatile, but it will be the speed will be faster in this case. So we usually see the short form like SSD. Okay. Then when we see about the storage, we can organize them in the form of speed and cost, or volatility. Volatility. Okay. So then we have two more definition. One is caching. Caching is nothing but a memory where a commonly or frequently execution part can be stored for faster execution. So copying information into faster storage system, when memory can view as a cache for secondary storage. So whatever the information that is in the cache memory, it will be retrieved faster. Okay. Then we have device driver for is device controller to manage input output. So device driver I have just mentioned before also, it's going to make sure that the particular device works properly. Okay, so if you see this, this is your storage device hierarchy. So here it gives based on your cost and the speed. Okay, so first we have register, then we have cache memory, then we have main memory, then we have solid state drive, then we have hard drive, then we have optical drive, then we have magnetic tapes. So these are the different storage devices available. Okay, and this is their hierarchy. So as we mentioned before, what is a cache? So caching is nothing but it's an important principle performed at many levels in a computer, can be either in hardware, operating system, or software. So in this information in use copied from a slower to a faster storage temporarily. So when we use caching, so your information is temporarily copied to a location which is in faster. So this faster storage or cache check first to determine if the information is there. So if the information is there in the cache area, then information will be used directly from that cache memory, and it will be fast. In case if the information is not available in the cache area, then wait, how? Okay, so so in case when an information is available in the cache memory, it will be retrieved directly, and in case it is not available, then your data will be copied to the cache and it will be used later. Okay, and you'll have your cache memory smaller than the storage being cached. Okay. So everyone just everyone just give your attendance through the link in your chat box. Okay, the link is there in the chat box. Just give it, and within 10 minutes this meeting will be closed automatically. Okay, this Zoom has 40 minutes time limit, so it will end it automatically. Okay, so everyone just give the attendance. So we have around 54 students. Okay, so then caching, then the link will be active till 11 o'clock. Okay, then we have this direct memory access structure. Okay, so we have, this is nothing but your, like, it's going to use your high speed input output device able to transmit information at close to memory speed. So structure is going to give a better speed. Then your device controller transfer blocks of data from buffer storage directly to the memory without CPU intervention. Okay, only one interrupt is generated per block rather than the one interrupt per byte. Okay. So we have this computer system architecture. Okay. I think I'll finish till here. Then computer system architecture. I will continue tomorrow. Okay. So everyone, if you have anything, just tell me. Any question, any problem, or any suggestion? Like, am I going too fast? I thought that I haven't on the videos. Am I going too fast or am I going